Hello and welcome back to Maths with Mitch. Today we are continuing our series on algebra and looking at collecting like terms. So let's make a start with talking about what is a like term. So we've already looked at a few things in algebra of how letters times together and things, but let's just consider we have some terms. That's next. Those lines do join together. Don't let your eyes deceive you. Let's consider this equation here. Now we're just going to talk about the terms. It's not going to equal anything at this moment in time. Just want to talk about it. So we've already talked about x or y or any other symbol and talked about it as being a variable. But we can also talk about it being a term. So that is a term. And yeah, y is a term. And in this instance, we have a term here, which is xy. So xy is also a term. So they're all variables, but we can say the x term, the y term, and the xy term. So it's just some different terminology where we're referring to a specific variable in the equation. So the first thing to think about is terms. So we've now got three different terms in this equation, but the variables are always a single letter. So we've got an x and y are two variables, but when you times them together, so you get the xy term, so they become terms. Now what do the numbers on the front mean? That is 5 times x. We've previously talked about why that is the case. Same as we've got a negative 3 times y is the coefficient there. And that, I've jumped ahead to what the end result is going to be there, but we are talking about coefficients, so that we're going to call them coefficients. So they are the coefficients of the terms. So here you've got positive 5, here you've got negative 3, and here you've got positive 2, lots of the xy term. So that's the notation and terminology I want to talk about. So we've got coefficients of terms. And these terms themselves are made up of either one or multiple variables in the equation. So next we come to a concept of collecting like terms, and that's hopefully why you're here. So we could have an equation such as 4y plus 3y minus 2z plus 5y minus 3x plus 4z. Now we've got a whole host of different variables there, and these are all single letters, though they're all different terms. Let's write this out so that it's actually vaguely correct to what I want to talk about. That should be an x there. Okay, so they're all different variables, but they're also different terms. And what we can do is, because they're all added or subtracted together, we can change the order of them. There's no brackets here, so we can do what we like with them here. So we can rearrange that and think about, let's get our terms that are the same or like terms, and let's collect them together to then be able to simplify an equation. So let's look at the x term. So we have 4x, but we also here have a minus 3x. So the big thing to remember is the coefficient on the front of the term carries the positive or negative before as part of its coefficient. So that determines the value of the coefficient. That is, it carries the negative or positive sign with it. Okay, so that's the first thing to remember here when we're collecting like terms. So next we can look at the y terms. So we have a minus 5y here, and we have a plus 3y. Now it doesn't matter which way around I write them because they're carrying the coefficient with them. So if you have a negative 5 plus a positive 3, you end up with negative 2. Likewise, if you'd written it the other way around, a positive 3y and a minus 5y, you still end up with negative 2. So as long as it's carrying the positive or negative with it, It doesn't matter which order you write them in. And lastly, moving on to the z's, we have minus 2z plus 4z. So the next thing we can do, we've collected like terms there, we've put them together, but now we can simplify those into a single, so that into a single value. So we just simply have 4 minus 3x, so that's going to leave us with 1x. Remembering that 1x we can just write as x. Next we've got a negative 5 plus 3y, so that's a negative 2y. And for the z's we have negative 2 plus 4, so that leaves us with plus 2z. Now remember, just as a little refresher on positive and negative numbers here, in case anyone was lost there, we can think about the number line where we have 0 here, and remembering we have negative numbers beyond 0. So here for the z terms, we said we had a minus 2z, so we were here, we're at minus 2, and we added 4, so we added 1, 2, 3, 4. So we've ended up at positive 2, so that's why we've got a positive 2z. And you can do that if you want with the y terms, and I'll let you do that yourself and prove that negative 2y is the correct value. But that is the end point. You've collected like terms and simplified, so that is the kind of thing you're going to be looking for. So finding your like terms and then simplifying them down. Now at the start we talked about an xy as a term. So let's now pick another example. Okay, so this is a new example where you can say collect like terms and simplify. So don't be scared by the xy term. It's a term exactly the same as what we looked at before. And in terms of collecting like terms, you can manage that in the same way as you did with it, as we just did with it being z. So remembering x, y in this case are the two variables, but x, y times together now becomes a different term. And so when we want to collect like terms, we have to look at the x term, the y term, and the xy term. So firstly, let's rearrange and put the x terms together. So we have plus 2y, remembering that if there isn't anything in front of it, it is a positive. So that is a positive 2x, minus 2x. That's here. We have a plus 3y plus 7y. We then have a, remembering this, it carries the positive or negative with it, so a minus 5xy and a minus 3xy here. Okay, so we then simplify, so 2x minus 2x, well that ends with 0. Now you can write 0, but we don't need to in this case. If for an exam you want to write 0 to show that you've proved it, or you can say that they cancel out, you might see people write things like that, or cancel to 0 or something. But if you want to put in that step to illustrate to the examiner that you've cancelled those and considered them, you could write something like that, or you could write 0, or make a note at the side, whichever is proving that step to the examiner. Then we have 3 plus 7y, so that leaves us with 10y. Now here we have a minus 5 and a minus 3. Now what we're not doing is remembering on your number line, in fact let's just go back to this number line so I don't have to draw it out again. We're starting off at a minus 5 and we're now saying we're going to minus a further 3. So we go 1, 2, 3. So we end up at minus 8. Now remembering when you did positive and negative numbers and you talk about two minuses make a positive, that is correct. And that would be the case if this was a minus, but it's not. It's just simply, it's minus 5. Your start point, minus 5. And you could say this is plus minus 3 or a minus positive 3. It's not a negative, it's not a double negative, okay? So that's an easy mistake you can make, but think about it on the number line. You've started at minus 5, you're then going to minus a further 3. It's not a minus, okay? So you end up with negative 8 x, y. And there we are, that's collecting like terms and simplifying for this one. So the takeaway points are variables are letters of the alphabet commonly, but terms can be either the letters on their own or when you have things times or divided by one another, they become a term in themselves. And remembering that when you collect them together, they carry the positive and negative symbol with them, and that'll make sure that you're going to collect them in the correct way. So that was collecting like terms. Thank you for watching. Please leave a comment at the bottom of the video if there's something that I'm not explaining very well, or if there's something specific you want me to cover. Thank you very much.